Assalamualaikum. Hi guys, in this video we are going to learn how to answer example 7, which is still about emission series of hydrogen atom. So in this case I have Paschen series. So for Paschen series, I'm going to determine which of the line in Paschen series corresponds to the longest wavelength of photon. And you have to describe the transition that gives to the rise of that line. So let's go to the first information. You have to write down where the ground state for Paschen series. So the ground state for Paschen series will be always n equals to 3. The next part, I'm going to determine which will be my first line or my first transition. So my trick before, for the first transition, the gap between line should be the largest one. So in this case, you have the gap between A and B is the largest one. So automatically A will be the first line. So I'm going to label this one as the first transition, second transition, third transition, and so on. So the next part, I'm going to label each of the ground state for them will be always n equals to 3. So this one, n equals to 3, 3, 3, 3, and 3. And now we go to the first number for the first transition. The higher energy level for the first line after 3 will be n equals to 4. So the first line A will be from n equals to 4 to n equals to 3. And next so on, you have this value for the next lines. Now, to do the solution for this one, it asks you which one is the longest wavelength of the photon. So you can see from here, A is the first line. Automatically, the energy for this transition of the first line A will be the lowest. So when energy is the lowest, you have the formula Hc over lambda for energy. You got the lowest energy, so of course it will have the highest wavelength. So now the question asks you which one has the longest wavelength. So of course it's going to be the first line, which is line A. This is the first answer. Next, it asks you to describe the transition. For this line A, you are going to write it down as electron moves from n equals to 4 to n equals to 3. That's why you will have the formation of first line in Paschen series. Now we go for example 8. I need to describe the transition of electrons that lead to lines W, X, and Y. So we are going to describe based on this series. This is Balmer series. So the energy level for the ground state will always be n equals to 2 for this series. So we are going to have 2, 2, 2, 2 for each of the line at the bottom to indicate the lower energy level. Now I'm going to determine who is going to be my first transition. As I mentioned before, the first transition is the one that has a bigger gap between first and second line. So what you have here, this is the biggest gap. So automatically this is going to be the first line. So I'm going to label this is as first line, and this is the second, and so on. And next, we have here the first line. The number next to number 2 is number 3. So this is from n equals to 3 to n equals to 2. W is 4 to 2. X is 5 to 2, this one 6, this one 7. So we are going to do our solution right now, which is specific for each of the line that the question asks for. So we are going to write for W first. Transition of electron is from n equals to 4 to n equals to 2. Next, you have for X from n equals to 5 to n equals to 2. And last, Y is from n equals to 7 to n equals to 2. So this is how you want to describe the transition. Let's try one last example for emission series where I have here is the diagram that depicts the line spectrum of hydrogen atom. Line A is the first line, so I'm going to label this one as the first line because you can see as well the gap between first and second is bigger. Now you have to draw the energy level diagram for corresponding line spectrum. The keywords here is this series, Lyman series. So automatically the ground state will always be n equals to 1. And now all of them will be 1, 1, 1, 1, and 1. And for the first line, it will be 2 to 1, 3 to 1, 4 to 1, 5 to 1, and 6 to 1, and so on. So I'm going to draw my energy level diagram based on this line spectrum. Let's go to the solution for this part where I have here my axis. Y-axis is for the energy. And the next one, I have each of the energy level. I'm going to start as n equals to 1 until n equals to 6. So what I have here, my first line is what we call as line A, followed by B, C, D, and E. So I'm going to start my first transition, n equals to 2 to n equals to 1. So I will have my transition of electron fall back down from n equals to 2 to n equals to 1. So this is what I have for line A. I'm going to label at the bottom of the line. Next, I have line B from n equals to 3 to n equals to 1. Next, line C, I have here from n equals to 4. Next, I have line D from n equals to 5. And last but not least, I have line E from n equals to 6. And all of them will fall back down. That's why you have to draw the arrow pointing down to indicate the energy emission in form of photon for that specific electron in hydrogen atom. So this is how you draw the energy level diagram based on Lyman series because all of them shares the same lower energy level, n equals to 1. So that's it for this video. I hope you can master how to describe the emission series of hydrogen atom. That's it for now. I'll see you in the next one. Bye!